Hello everyone, my name is Hemu and today we are going to discuss one more most asked interview questions, which is what happened when we type or when you type a URL into your web browser. Let's suppose I have this particular topology where I have couple of PCs here. I have my access switch. This is my access layer. Here I have my users or my servers. Then I have a core switch. Then I have a firewall. Then I have an internet service provider. And after that, this internet service provider or ISP has a connectivity with the other part of the internet, right? Now, what used to happen, like they will ask this particular question in this way. Can you explain when this PC, we have just started this PC, or when we have turned on this PC, what will happen? Or when we have opened the web browser into this PC and when we have typed like www.facebook.com. Now, what are the series of activities which is performed on this particular PC, right? So all these type of things we are going to discuss. And in my EVNG, I am having a similar type of topology, guys. But I do have a similar type of topology. If you will see here, I will initiate a traffic from this test PC. This test PC is a part of VLAN 20. I have a test PC2, which is also part of VLAN 20. I have a test PC3, which is a part of VLAN 30. And I have a Windows test PC3, which is a part of VLAN 40. This is my access layer core switch 1. This is my access layer core switch 2. This is these are my access switch which are in the access layer, and after that I have my core switch. So this is my core layer. We have an access layer, then we have a core layer, right? And after that I have my firewall, and this firewall have a connectivity with the internet. And this particular switch, core switch, also have a connectivity with one of my local DNS servers. So we will see all these things, all the series of activities which is performed from this particular system. Okay, now how we can basically do all these things? So what I will do, I have a end-to-end connectivity, guys. So what I will do, I'll just go here. I'll start the Wireshark capture on this PC. You can see capture is started. Now I'll go into this particular test machine. In this test PC, I'll just open this web browser. And I'll go and I'll just type www.facebook.com. And you can see I got the login page of this facebook.com, right? It will load in some time here. Meanwhile, go here. Let me just stop the captures. Let me take the access of my firewall as well. So interface management and IP address is correct. I am just accessing the correct firewall. And in this file, you will see show session all. You can see there are a couple of sessions with Facebook. This is the actual session, right? And session ID is this. What is this session ID? I am going to explain you, but let me just open this session detail so we can refer this thing when I will explain the things. Okay. Okay, cool. I have my Wireshark captures. So this is my Wireshark captures here. or there are a couple of other traffic as well available, right? So to see the exact, let me just type facebook.com. No, it will not come like that. Then I have to check each and every packet. So they have basically did the updates towards Microsoft.com and other things. There is some standard query towards wpad.local, this website. Google.com, there's a query for google.com. I just wanted to see for Facebook, and after that we will start basically doing the things. What I can do, let me first explain you the theoretical part of it, and after that we will basically look for the capture and other things, because there are so many captures. So what I can do, let me do one more thing. Let me open here this browser in incognito mode. Let me close this one. Now I'll go here. So guys, what used to happen whenever basically you will type a URL into the web browser of, let's suppose, on this computer. So what will happen in this computer? What it will do in this computer, what it will basically, the very first task which is performed by this computer is DNS resolution. What it will do, the DNS resolution, and I think this DNS related information I have already explained into one of my lecture, right? So in DNS resolution, let me just give you the brief about it. What this DNS resolution, what we will do, because we have basically typed facebook.com into the browser. So what it will do, for Facebook, basically my PC will try to find the IP address, and when it will try to find the IP, what it will do, the very first thing what it will check is your browser cache, because each and every browser, they used to cache the IP to mapping, IP to host, IP to domain name mapping. So that information he will try to get from the browser cache. Means it will check like facebook.com is available into the browser cache. Do I have the IP address of facebook.com? If yes, then basically it will start communicating with the facebook.com. The second thing, it will basically check the browser cache. If info is not available, then it will check the operating system cache, because Windows operating system will also basically maintain the cached information. It will maintain the DNS cache information. It will look for that info, that detail, and try to get the IP address. And after that, what it will do, it will basically check the host file, right? These things already explained, right? Then host file, if he will get the detail. Otherwise, if he will not had get the detail, then what it will do, it will basically try to communicate with the local DNS server. It will try to communicate the local DNS server. Let's suppose IP address of your local DNS server is 10.1.99.220. So what it will do, now from this PC, what he will do, the now he will try to communicate with this 10.1.99.220. So what he will do, he will basically what he will do, he will just check the ARP table. He check the ARP table, because when he will try to communicate with this one, he will forward that data to the default gateway. Let's suppose the default gateway IP address is here. This is our default gateway. So what he will try to send that packet towards the default gateway, right? So what he will send the ARP request. And this ARP packet is the broadcast request. This is the broadcast request. And he will ask into this ARP request, can I have the MAC address of 10.1.1.1? This packet is when this broadcast packet received by this switch. This switch, what it will do, it will basically forward this ARP request into all the ports which are a part of VLAN 10. And also it will forward this particular ARP packet into all the ports which are in the trunk where we have allowed the VLAN 10. So means all the ports which are a part of VLAN 10 and all the trunk port where we have allowed VLAN 10, they will basically, so this switch will do the broadcasting of that particular packet. Now when this packet reached here into this switch, because on this switch we have this IP address, so this core switch will provide the MAC address of 10.1.1.1 is this. So what it will do, it will do the ARP request first and it will get the ARP response. Once he will get the ARP response from this PC or from this layer 3 switch, or when this PC have get the get the MAC address of 10.1.1.1, now it will basically create the Ethernet frame and will basically forward the request. What it will do, it will now it will basically try to forward that request towards the switch. So now let me just draw that part as well. Now this request basically is forwarded to this switch. This switch will forward to this core switch. Now this core switch will forward this request towards the local DNS server. Now when this request reaches to the local DNS server, so what will happen? Now this local DNS server check his cache memory, right? If he will have the detail of that particular facebook.com IP address, if he is having that IP, he will provide, right? And guys, this particular DNS query, which is received by the local DNS server is the recursive query. And you will see RD flag is set 1, means it's a recursive query. Recursive query means now this local DNS server responsibility to provide the IP address of facebook.com. So what will happen now, this particular local DNS server will try to communicate with the root DNS server, or let's suppose we have defined the forwarder as the public DNS server, then this request reaches to the public DNS server. And this is also a recursive lookup. And after this, public DNS server will communicate with the root DNS server, then com DNS server, then Facebook DNS server, and finally it will get the IP address. And whatever communication is happening from this ISP DNS or this public DNS, what it will basically do the iterative DNS queries. Okay, once he has the IP address, he will provide this IP address to this PC. Once this PC get the IP address, what it will do, the very first thing after getting the IP address, what it will do, now it will basically start the TCP three-way handshake process. And in TCP three-way handshake, what used to happen generally? Let me just write down the detail here. Now in this TCP three-way handshake, what it will do? It will basically send a TCP SYN request, and this request is received by the firewall. It's a TCP SYN packet. Now, what this firewall will do now, this firewall basically start processing this TCP SYN request. What it will do, it will basically start processing this request according to the packet flow in your Palo Alto firewall. Let's suppose if it's a Palo Alto firewall, then this SYN request first go through with the ingress stage. Then this request go into the flow lookup stage. Ingress stage flow lookup, then this packet will go through the silo path. In silo path, this firewall going to basically apply the routing, right? It will apply the net rules, it will apply the security policies, your zone protection policy, your DOS policies, all these checks, all these policies it will apply. And if my security policy and other policies allowing this packet, what it will do, it will create a session and it will forward this packet towards the fast path. In fast path, your net translation happening, because this particular packet coming from the private IP address, it is going towards the internet, right? So now it will perform the net. Then this packet goes into the forwarding stage. App ID and content ID is bypassed by the firewall for this packet, because TCP SYN is not having any data. And now finally this request reaches to the facebook.com here. Now Facebook will reply with TCP SYN plus ACK. Now this TCP SYN plus ACK is received into the firewall. Now firewall basically again start processing it, will send through ingress lookup, ingress stage, then flow lookup. That time connection is already created, right? This time it will found the flow, so it will bypass the silo path. It will forward this packet to fast path, and it will basically forward that packet into the forwarding stage. Then packet received by the layer 2, this core switch, then your layer 2 switch, then finally packet reach to the PC. So that's how basically things happens in this particular environment. And guys, once this TCP three-way handshake will complete, what will happen? The sixth one, they will start doing the SSL handshake, because facebook.com is a HTTPS website. Once SSL handshake will complete, what they will do, now they will basically exchange the Facebook data, or I can say application data. Means now your actual Facebook data they will exchange here. Okay, so these are the series of activities which is performed by this PC till this particular Facebook server when they are communicating with each other. Okay, now what I can do now, let's try to basically see the same thing again. So there is a lots of data is already there. Let me just look for this specific data. I'll go here into my firewall, and this is the IP address of facebook.com. I'll go here, type IP addr equals. This is the TCP SYN. Then we have SYN plus ACK. Then we have a ACK, right? Then we have a redirect message, right? With this, and now I'm going to explain this part only. Let me just see. Packet number is 372. This is the packet, right? 372. So I'll go here. If you will go here, if you will see, it has basically this PC 10.20.1.1.200 is the PC from where we have initiated this connection. It has just communicated with the local DNS server, which is 10.1.1.220, right? And he has forwarded the DNS request. In this DNS request, what he has asked, can you tell me the IP address of facebook.com? Now you will get the DNS response from this local DNS server. In this response, you will able to see www.facebook.com. You can go into this answer section. www.facebook.com IP address is 157.240.198.35. So we will get the response, right? And as soon as we will get the response, you can see the very first packet, HTTP send request. So here we have, you can see we have they have a two SYN, because this is a browser. Sometimes they will create a two connection. So that's not a big deal. Then SYN plus ACK, then ACK, right? SYN plus ACK, then ACK. And after that, you can see they have basically sent the normal HTTP request on port 80. This communication is happening on port 80. You can see port 80 is here, because we have typed www.facebook.com. So what will happen? My browser try to communicate on TCP port 80. But facebook.com is hosted on TCP 443. So what you are getting? You are getting the reply in a form of HTTP. You can see HTTP get. This is the packet is sent by us. HTTP get request we have sent to access www.facebook.com. This is the request URI, right? And you can go here and you can see we got this particular, we will get this particular reply. This is the response, right? And this response has a HTTP code 301. And this HTTP code 300 generally we will use for the redirect purpose when we want to redirect, right? And you will get the details here. Let me just open. See, this particular website has been permanently moved. Where it is permanently moved, and we are using HTTP version 1.1, right? This is the response. Location, see, this www.facebook.com, this www.facebook.com is moved, and the new location is https then www.facebook.com. This is the new location of that website. You can able to see, right? We will get this detail here. This is the original request URI, and this request has been moved here. Now you can see, if you will go on top, now you can see, now they have, because again they have exchanged SYN, then acknowledgement, SYN plus ACK, then ACK, right? And again now they are doing the communication over SSL, and so you can see the client hello packet here. In this client hello, you can go and you can check the SNI field. You can able to see into the SNI field server name indication. We are communicating with the facebook.com, and this time you can see port number is 443, right? And now they are basically using TLS security, transport layer security. They are encapsulating packets over the TLS header. And after that, you will get the server hello, change Cypress pack application data, right? And after that, what this application data is the Facebook data, which is encrypted. You cannot able to see anything here. So that's how the main communication used to happen in this particular case, guys. Let me just see if I can able to show you the see, if you will see this particular packet, this is the ARP packet. What happening? My client PC, which is 20.1.1.200, trying to communicate with 10.1.1.220, and it is trying to communicate with the client services.googleapi.com. So what, because 20.1.1.200, if I'll go into this PC here, if I'll open this particular command prompt, if I'll type here ipconfig/all, you can able to see this is the default gateways. 20.1.1.1 means it will try to communicate on this IP address, right? So you can see it has sent this ARP, he has sent this ARP request. Who is having this 20.1.1.1? Because according to this topology, this 20.1.1.1 is available into this core switch. You can go and you can check this core switch. You have to run this command. So IP interface brief. You can see here I have a VLAN 20 and VLAN 20 have IP address 20.1.1.1 means I have created the SVI here. Okay. Switch virtual interface. I have configured 20.1.1.1 IP address. And this is the L2 switch right now. If you go here, if I will basically open this broadcast packet, this is the address resolution protocol, right? You source MAC you can able to see, destination MAC you can able to see, right? Now you can go here. Sender MAC address is this. This is the MAC address of my Windows machine. Windows PC or test PC. This is the MAC address of my test PC. Windows machine, this is the IP address. Target MAC address is this. And target IP address is this. Means we are looking for this particular IP address. Now you can go and you can see here. We will get the ARP reply. In ARP reply, we will get target MAC address is this and target IP address is this. And they have asked like 20.1.1.1. Sender MAC address is this. Sender IP address is this. Means he will get like 20.1.1.1 is on this particular. This is the MAC address of 20.1.1.1. And even though if you will go here into this PC, if you will run this command R-A, you can able to see 20.1.1.1 having the MAC address which is 50.00.00.03.80.14. 8014. Here why I am not able to get the broadcast packet, because you know I think broadcast it has already generated first time. That is the reason. Okay. So that's how they will basically use to do the communication. Because if I'll go on top here a little bit more, if I can just wanted to see if I have any other ARP query. No, I think I have not captured that part. Cool. What I can do now. So now if let me just tell you the short story here, what will happen when you will type. I have opened the PC. When I will type in PC browser, when I will type facebook.com. So what will happen? The very first thing, this PC try to do the DNS resolution. In DNS resolution, what it will check the browser cache. Then it will check the local host file. Sorry, browser check. Then it will check the operating system cache. Then local host file. And after that, if he will not find the detail, now it will try to do the communication with the DNS server, right? So to do that communication, what it will do, it will basically, because you know this DNS IP address we used to configure, right? So what it will do, it will check the routing table. Means your PC will check the route table. Is from this route table, what it will try to get the default gateway detail. Let's suppose from the route lookup, it will get the default gateway is 20.1.1.1. Now what it will do, now it will basically now it will try to find the MAC address of 20.1.1.1. So it will check the ARP table. If MAC address available into the ARP table, which is good. If not available, then what it will do the ARP lookup. And it will try to find out the MAC address of 20.1.1.1. Once it get the MAC address by doing the ARP lookup, what it will do? Now it will basically try to communicate with the local DNS server. Now this local DNS server will further communicate with the root DNS server, right? Then com DNS server, then Facebook DNS server, and it will get the IP details, and this local DNS server now update this IP detail to this PC, right? Now this PC will start doing the TCP three-way handshake. Right? Now it will do the TCP three-way handshake. And once TCP three-way handshake will complete, now what they will do? They will do the SSL handshake. Because facebook.com is a HTTPS website. Once SSL handshake will complete, now what they will do? They will basically exchange the Facebook data. So these are the series of operations performed by this particular PC. And if you want to add more detail, like when we will type facebook.com, like when we open the browser, in browser we have opened the new tab, right? When we have opened this new tab, that time this browser basically assign one port number to that particular browser tab, right? So there are multiple things also happen in a backend, but I will not go in that much depth there. But if you will know this particular information, which is good. Remember one more thing here. Now maybe sometime what they will ask in this in your interviews, maybe they will add some points that they will ask. After DNS, we got the IP address of facebook.com, but now user is not able to communicate with the facebook.com. So maybe you have to ask, if we have a firewall in middle in the path, we have to check, is this firewall is allowing this traffic or not? Maybe firewall is blocking the traffic, right? And so sometime what happens, let's suppose on this firewall we have configured the security policies on the basis of URL filtering, or maybe on the basis of app ID. So maybe they will say, like, we have checked the firewall and we have seen SSL, like TCP three-way handshake is happening with the server. SSL handshake is also happening with the server. But somewhere in SSL handshake, and or maybe in your, when they are exchanging the application data after SSL handshake, we are not able to see any further packets. What is the reason? So there's the reason behind this, maybe your firewall is blocking the packet on the basis of URL filtering and app ID, because you know in SSL handshake, when we will exchange the client hello message, from this client hello we have this SNI field. From this SNI field, my firewall extract the domain name of the website and it will do the URL lookup, or it will do the lookup for that domain. It will check what is the configured rules we are having on the firewall for this particular URL. We are blocking, it will block that traffic right away, right? So like that, you have to basically explain if there is a firewall in between. Okay, now what I can do, let me just close my Wireshark captures here. I'll close this Wireshark capture. I'll go here, close this as well. Let me close my browser as well. I'll go into this incognito mode only. I'll go here. I run this command arp r-al. This is the arp right now I'm having. I will go and I will just type r-d. I will delete all the arp. Okay. I'll go into my local access switch 1. Clear MAC address table. Dynamic. I will clear the MAC address table here. I'll go into my L3 switch and I'll go and I'll type clear R cache, clear MAC address table, dynamic, right? Now I'll go into my topology. Now what I can do, I'll basically go here. I'll start my capture and this time I will do the capture on gig 1x1 interface. This is the very first captures. I'll do the capture on gig 1x2 interface. And I'll go and I'll do the capture on interface which is gig 1x0. Now I'm capturing this particular traffic onto all these three interfaces. Let's see. So this is the first capture. Let me just decrease the size of it. This is my first capture. There's a continuous communication with this DNS because this Windows machine, it is basically creating this traffic, generating this traffic by default. And whatever I want to explain, I'm not able to explain you with these captures, guys. Sorry for that. What I can do, I will basically use this particular device because this is my router device and it will not generate the unnecessary traffic because these Windows machine, they will communicate with the different servers and all, right? And what I can do, I'll go here and let me just put this particular interface on this L2 switch into VLAN 30. Okay, just for the shapers, so we can I can able to explain the ARP communication as well. So I'll go here into layer 2 switch, config do so run interface gig 1x2. Remove this VLAN 40 and remove VLAN 30. Do so run interface gig 1x2. It's part of VLAN 30. Do right mem. Conft. Let me configure this host name. iOS test PC03. Interface F0x0. And IP address is 30.1.100.255.255.255.0 and no shutdown. Exit IP route 0.0.0 30.1.1.1. Do right, ma'am. Now I will generate the traffic from this test PC actually. Okay. Now I'll go here on this. Let me just take these three captures. I will take on this interface 1x0. I'll take on 1x1. Then I will take on 1x2. Then we have a second one. Then I have a third one. Right now you can see we have not any such type of traffic. Now if I'll go here into this machine, if I run this command show MAC address table, we don't have. So ARP table, you can see we have a we just have a ARP for this IP because this is a static ARP, right? This IP address we have configured on this particular router only. Now what I will do, I'll go and I'll just type ping to. I think ping will not work because I have to configure the DNS. So I'll go and I'll just say ping to 8.8.8.8. Somehow this ping is not happening. 30.1.1.1 ping to 30.1.1.1. Till here ping is working. 80.8 not working. This is some different thing. What I'll check now. I'll go here. Now I'll go here and I will just try to check the packet on Ethernet gig 1x1 interface. So you can go here and just look for this particular packet. So we have received one broadcast ARP here, one broadcast packet for ARP request. Let me just increase the size a little bit. Now on this ARP request, what we are sender IP address is 30.1.1.100 and we are looking for this particular IP address like target IP. What is the IP address? My default gateway 30.1.1.1. What is the IP address of this particular host? This is the ARP packet basically is forwarded by this PC. This is the IP, this is the MAC address of this particular test PC or this router, right? This is IP address and the target MAC address all zeros. Then we are doing the ARP lookup for this IP. And we are getting this ARP reply. In ARP reply, we are getting 30.1.1.1 available on this 50.00.00.03801E. This is the MAC address of this particular IP address. And who is sending this MAC reply? This particular device is doing the reply. Now, if I'll go and I will just show you this capture. And you can go here. This is the sender IP address. I want to see this broadcast one. Sender IP address this, and we are looking for this. And you can see this is the broadcast packet. This packet is also forwarded towards this interface as well through this interface gig 0x1 because this is the first capture which is a part of gig 0x1 interface, right? And we are getting the reply from that interface only, right? And the last capture you will be able to see. See, but this is the broadcast packet. It is also forwarded towards that VLAN, right? But we have not seen any reply. Reply is only coming from this interface. So as I have mentioned on my explanation, when this PC, what it will generate the ARP request, this ARP packet received on this interface, on this layer 2 switch. Now this layer 2 switch do the broadcasting. It will forward this packet on trunk interface and on all the ports which are part of VLAN 30. And this request reads to the core switch. Now core switch will reply with the MAC address. And if you will go here, and if you will go into this switch, if you run this command, so interface VLAN 30, You can see sender MAC address is 50 5000, then again 03 5000 801E. 801E means see this is the MAC address which is configured available on that interface VLAN 30, and this is the MAC address received. Okay, and after that, see, it has sent the ICMP request, but we are not able to get any reply. See, ICMP request is there, but we have not seen any reply. This is a different thing. Why reply is not coming? Maybe I have to check on my firewall. I have configured the rules properly or not. Okay, but for the safer side, let me just check. So IP route, I have the proper route. I have this default route pointing toward that host. Let me go into my firewall. Let me try to ping source 10.1.1.250 to host 30.1.1.100. See, a ping is working, means this firewall have the routing as well properly. Now let me go here. Meanwhile, guys, let me just log in into my firewall. Meanwhile, this login is happening on the firewall. Let me just tell you guys, this is my YouTube channel, and all these videos you will get into this particular YouTube channel, right? So what you can do, you can basically subscribe this particular YouTube channel, and in when you have to like type youtube.com/@Hemu-Sir videos, and what you can able to land into this my YouTube channel, and here you have to subscribe, so you will get all these type of videos. We do have another channel, and the channel name is Skilled Inspirational Academy. You can also subscribe for this particular channel. Both YouTube channel belongs to us, guys. And one more update, guys, if you will see here, we are starting one advanced FI advanced web, which is also known as ASM batch, along with the Palo Alto. It's a combo batch which we are starting from 30th of July, and it's a weekends batch, guys. Means these classes will happen Saturday, Sunday, starting from, so for ASM, your classes will happen between 10 a.m. to 12:30 p.m. Means we have around 2.5 hours of session on Saturday and 2.5 hours of session on Sunday. And once your ASM classes will complete, we will start your Palo Alto classes, and Palo Alto classes will happen between 9 a.m. to 12:30 p.m. So guys, where we have around 2 hours 30 minutes of class, and after that we have a question and answer session. Basically here you can able to ask your doubts, Q&A, everything, right? So if you really interested to attend this particular classes, you can basically watch the demo here. Demo video is available here, right? And the fees for this particular training is 12,000 INR if you will enroll for combo, and if you will enroll for separate batches, then you have to pay 10,000 for ASM, which is WEF, and 7,000 for Palo Alto. And guys, your Palo Alto classes will happen on PanOS 11, which is the latest version. Okay. So this is the one update, guys. What you can do if you want a more detail regarding that, you can basically contact us into these mentioned numbers. You can able to see in this screen, these are the numbers which is mentioned, right? So you can contact us on these numbers. You can able to do WhatsApp also on these numbers. This first number belongs to me, and second number belongs to Bedet sir. So you can able to contact us on these particular numbers, guys. So this is the one update which I wanted to tell you. Maybe this traffic is not working. Looks like I don't have a rule on my firewall. That may be a reason. So I have a LAN subnet allowing towards outside. This traffic I'm allowing. Let me go for the net rule. So guys, there's a multiple thing which you have to check. You can see ping and trace out is also I have allowed here. Let me go into this net. Let me just check. I have a net like for DMZ LAN subnets is the IP belongs to this, like object LAN subnet. Let me just see. VLAN 10, 20, 30, and 40. Let me go into address object 30.1.1.0/20. 40.1.1 means I have a security policy. I have a security policy here, which means ping should work. Ping to 192.168.1.1. Till here ping is working. 8.8.8.8 with the repeat count of 20. Ping is working, guys. See? Previously it is not work, maybe due to ARP and other things. That is the reason, but now ping is working, right? So things are good now, right? So session all, we have a session. Okay, so guys, that's how traffic is processed when we will type a URL into this particular web browser. If you want to see more detail, like I have mentioned, DNS resolution, ARP lookup, TCP three-way handshake, SSL handshake, then HTTP request response over TLS header. Browser checks the cache. This already explained, right? If the not found cache, then it will go DNS lookup and other thing. Then they will do the TCP three-way handshake and all these things, right? So that's how they used to basically explain the things. Okay. One more thing, guys, or what I wanted to, I will basically take this thing in some different classes, like what are the component is available into an URL, right? So this thing maybe I will take into some different lecture. So that's it, guys, which I wanted to cover with regards to this particular lecture, like what happens when we type a URL into this web browser. Maybe now you can add, there are a hell lot of things which you can add. Maybe on this you can say whatever interface we are having which is connecting to a core switch, maybe this interface is a part of trunk but VLAN 10 is not allowed. In that case also your access will not be, because this switch will not forward this data through this interface because VLAN 10 is not allowed. Maybe when this packet reaches to the core switch, now in this core switch you have to check we have a proper routing towards the firewall or not, right? If this data reaches to the firewall, now we have to check on this firewall we have a, like we have allowed this particular traffic into our security policies or not, we have a proper net rule or not, right? We have a proper routing or not. If all these things are good, then Fire will also process the packet, will forward towards the Facebook server. So there are multiple things which also you can include, guys. Okay, but here I will go with the basic ones, and I think this is more than sufficient basically for this particular question in your interview. Thank you, guys. Take care. Bye.